What in the world is going on with the Orion capsule's heat shield? Will this impact NASA's current schedule for a moon landing no earlier than September 2026? Let's dive into what's going on right now in the Artemis program. Artemis I launched in November 2022, and it was a very successful 25.5-day mission that took the uncrewed spacecraft a total of 1.4 million miles to the far side of the moon and back. It achieved all of its objectives, including some that were added on as the mission went along because everything was going so well. But one of the big anomalies that came out of this mission was the unexpected performance of the Orion capsule's heat shield. Basically, there was unexpected char, more liberation of the heat shield material than was expected during re-entry of the Orion capsule. And NASA is still figuring out why exactly this occurred. A new report from NASA's Office of the Inspector General highlights this issue as a serious obstacle to Artemis II. To understand what exactly is going on here and the implications for Artemis II, let's first go through exactly how Orion's heat shield works, and then I'll talk about this new report and what we know, and everything we don't. Orion is a crew capsule built by Lockheed Martin, but unlike the commercial crew program, which I talked about in depth in my video about Boeing Starliner's first crewed flight test, NASA owns and operates the Orion vehicle. They've been incredibly involved in every stage of development and testing, so they know this crew vehicle inside and out. When Orion re-enters the Earth's atmosphere at up to 25,000 miles per hour or 40,000 kilometers per hour, it's subject to temperatures of up to 5,000 degrees Fahrenheit or 2,760 degrees Celsius. The capsule and the astronauts have to be protected from this, which is why the capsule turns and re-enters the atmosphere with the blunt end of the capsule facing down. This is a very basic explanation, but when a spacecraft enters the atmosphere quickly, there's what's called a bow shock wave that forms around the capsule as it re-entered. Heated plasma forms around the vehicle. If you watch the re-entry video of SpaceX's Starship's third test flight before they lost the vehicle, you could see this plasma forming around Starship, which was pretty cool to see. In a capsule design, re-entering the atmosphere with the blunt end first means that 90% of the friction heat of re-entry is dissipated through the shockwave. That means a heat shield can do the rest of the work to protect the capsule and the astronauts inside it. Orion's blunt end is covered with an ablative heat shield. This means that it basically melts off during re-entry, taking the heat of re-entry with it. The heat shield, which is 16.5 feet wide and encompasses the bottom of the capsule, is made up of a material called AvCoat. This is a modification of what was used on Apollo capsules, though the Orion capsule is bigger than Apollo. The AvCoat is applied in blocks to the capsule, which is made of titanium and carbon fiber. Now, it is worth noting that this is different than the original design for Orion's heat shield. For the Exploration Flight Test, EFT-1, which occurred in December 2014, they had a large single-piece heat shield with a honeycomb design in which 320,000 honeycomb cells were filled with AvCoat by hand. They switched to this new piece-by-piece block design for Artemis I. After the blocks are installed and tested, they are then covered with a coat of white epoxy paint, then bolted to the crew module. The capsule also has backshell panels that cover other areas of the spacecraft, but what we're focusing on here is the ablative heat shield. Okay, so then what happened during Artemis I? As I said, the mission went successfully, but upon examination of the capsule after it splashed down, there was clearly some unexpected performance of the heat shield. We first heard about this in a post-flight update in March of 2023. What happened was that the ablative heat shield didn't melt, at least not fully. Instead of coming off in very small pieces and burning up, as was expected, in some places the material came off in chunks. That is not the way the material is supposed to behave. It's also important to note that Artemis I used something called a skip entry, which is new. The capsule dipped into the upper part of the atmosphere and then lifted back out again, and then re-entered again. This basically allows Orion to fly much further once inside the atmosphere, which allowed for both a smoother ride for the astronauts and a more precise touchdown. According to a press conference in early 2024, the bulk of the charred material liberation occurred after that first atmosphere dip, when Orion was pulling back out of the atmosphere. The report from the Office of the Inspector General describes the char as cracking and breaking off, and flags that because it didn't immediately melt away as expected, this material created a trail of debris behind the Orion capsule during re-entry. That's not good. While there was no evidence that the char affected the capsule, if it had impacted Orion, it was enough material to have caused a failure in one of the parachutes. Of course, Orion has 3 parachutes and can suffer the loss of one and be just fine, but you never want that kind of risk. It is also very important to note that NASA has made clear if crew had been aboard Artemis I, they would have been absolutely fine. They wouldn't have even experienced any excessive heating. The heat shield is designed to keep temperatures in the cabin around 70 degrees Fahrenheit or 21 degrees Celsius, and that happened during Artemis I. There would have been no impact to crew safety. But it is still important to figure out why this crucial part of the spacecraft is behaving in an unexpected way. Since they identified this issue, NASA has been working very hard on figuring out why this is happening. They want to understand the cause of the issue. It's part of why they chose to delay Artemis II to give themselves more time to understand what's happening. Now, if you're wondering, does it really matter? If the crew would be safe even with this charring, then why focus on this so much to the point where you're delaying missions? This is a lesson that's been hard learned by NASA. One of the key contributing factors to both major disasters during the space shuttle era, the destruction of Challenger and Columbia, was something called normalization of deviance. This is a term coined by Diane Vaughan. Basically, NASA has always been conscious of safety. That has always been paramount. The idea that was advanced after Challenger of NASA middle managers who compromised safety to achieve deadlines, that is a myth. But there was also an organizational culture that accepted deviance too readily. For example, when foam from the external tank struck the Space Shuttle Columbia during liftoff, no one thought too much of it. It had happened before. Why this foam was acting in a way it wasn't supposed to and falling off in chunks during liftoff, they didn't really know, but it hadn't affected missions before, and it was just foam, right? So it couldn't affect the heat shield of the orbiter. It wouldn't make a difference this time either. That was the thinking, and it got people killed. NASA is very aware of that. This is a quote from Amit Kshatriya, the Deputy Associate Administrator for the Moon to Mars program, on the heat shield at a press conference early in 2024. The lessons of our history is that even though we believe we understand and that our hardware is performing according to requirements, we have to be absolutely certain that we understand the integrated performance of that system when there are excursions from that performance. This is basically making sure they do not normalize the deviant behavior of the heat shield. They need to be 100% sure they understand how the heat shield will function under all circumstances and why it's functioning that way. So then, what's next? As I mentioned, NASA has been studying this issue closely for over a year. They tried to replicate this behavior, figure out why it didn't show up in their tests before, looked at whether the change in the Artemis heat shield design from EFT-1 to Artemis I affected the heat shield's performance. Everything they can do basically to understand this problem, short of launching another capsule up there. According to NASA's response to the OIG report, they were able to replicate the behavior, and they are working on a theory for the root cause of the issue. We'll likely hear about it in the next month or two when an independent review board looks at the results and delivers a report. Once this happens, the question is whether this will affect the launch date for Artemis II, currently scheduled for September 2025. And the answer is, I have no idea. Given the performance of the heat shield on Artemis I, it is possible that NASA will have to modify the heat shield design on the Orion capsule. It just basically depends on the reasoning for this charred material behavior. But if significant changes are required, it could delay the mission by a year or more. It's also possible that they could just change the re-entry profile rather than do a full redesign of the heat shield for Artemis II and save that redesign for later missions, if that redesign should become necessary. They could go back to direct entry like Apollo instead of a skip entry, since the bulk of the liberation of that charred material occurred on the lifting part of skip entry. It's basically just all about assuring that Orion is safe to fly for Artemis II. I'll provide another update when we get the results of that independent review board report, But for now, that is about all I have to tell you about Orion's heat shield. Thank you for watching. I am Swapna Krishna, and this is Ad Astra.